Hello everyone, the next topic is all about unit hydrograph. Unit hydrograph is defined as the hydrograph of direct runoff. In a direct runoff, there is no base flow. It is a combination of overline flow, which is found on the surface of the ground, interflow just below the surface of the ground, and channel storage, resulting from 1 centimeter depth of excess rainfall. And 1 centimeter is just a standard assumption. Excess rainfall or after all losses, after all absorption and filtration, then the ground gets saturated, then we can get the runoff or the surface runoff, occurring uniformly over the entire basin and at a uniform rate for a specified duration. Assumptions. These are the assumptions that will help us understand any problems on unit hydrographs. In order to get something or understand something, we have to assume in order to come up for a conclusion or a decision. One of the assumption is as effective rainfall is uniformly distributed within the specified period of time. Second is the effective rainfall is uniformly distributed throughout the area of a drainage basin. Third, the time or the base duration of the direct runoff of hydrograph due to an effective rainfall of unit duration shall be constant. Fourth is the runoff hydrograph due to a given period of rainfall for a drainage area shows all the combined characteristics. Combined physical characteristic not only infiltration but that also includes the nature of the soil, the steep slope, and etc. Next is the limitation. The unit hydrograph is based on the assumptions that effective rainfall is uniform over the entire basin. However, it is not particularly in case of a large basin. In a large area covered by the rainfall, we have to assume that the effective rainfall is the same in all areas, even if one area is sandy or the other area is full of rocks. Also, the moisture content is also not the same. That is why we have to assume that the effective rainfall is uniform in all areas. Second is that this theory is not applicable when the appreciable quantity of precipitation occurs in a form of snow. There are many forms of precipitation such as rainfall, snow, mist, drizzle, dew, etc. But majority in hydrology talks about rainfall. Next is the application and the advantages. First, flood hydrograph can be calculated with a short record of data. By analyzing the previous record, we can plot the flood hydrograph and take necessary measures for future disasters that may occur. Second, in addition to peak flow, unit hydrograph also gives total volume of runoff and in-time distribution. Third, unit hydrograph procedure can be computerized easily to facilitate calculating large data sets. This procedure can only be used for calculating large data sets or a larger time duration or rainfall date, because if you do it manually, it will take longer time to calculate. Next is the derivation and construction of unit hydrograph. We can see in the picture the distance versus time, or also can also be called as a discharge over time. We can also see the flood hydrograph at the upper layer, then below is the unit hydrograph and also the base flow. In the time, we can also see the end days or the number of days. All of this can be plotted once you get the data from the table that I'm going to show in the next slide. Next is the steps. First, in the past result, select some unit period of intense rainfall duration corresponding to an isolated storm uniformly distributed over the area. Second, plot the storm hydrograph for some days. After the selection of data with all the condition that is given or stated in step 1. 3. Separate the groundwater flow or the base flow from the direct runoff. 4. subtracting the ordinates of the base flow from the total ordinates in order to obtain the ordinates of the direct runoff. As I said before, direct runoff is the combination of overline flow, interflow, and channel without base flow. 5. Calculate the direct runoff in centimeter by the standard formula. Direct runoff is equals to 0.36 times the summation of all ordinates times time over area in centimeter, where the summation of O is equals to the sum of discharge ordinate or DRO in unit Qmix. T is equals to the time interval between successive ordinates in unit hours. A is equals to the area of drainage basin in square kilometer. Step number 6, we have to calculate the ordinate of the unit hydrograph by using this formula. Ordinate of the unit hydrograph is equals to the ordinate of direct runoff over the direct runoff in centimeter. We also have here the table, example table. In the first column we have time, second is flow, third is base flow, fourth is the ordinate of direct runoff, fifth is the ordinate of the unit hydrograph. Usually, the time, flow, and the base flow are already given. The only thing we have to solve is the ordinate of direct runoff and the ordinate of the unit hydrograph. To solve for the ordinate of direct runoff, we have to minus column 2, which is flow, minus the column 3, which is the base flow. Then next is to solve for the DRO, which is using the formula above. DRO is also 0.36 times the summation of all ordinate times time over the area. And once we get the DRO, we have to use this to solve for the ordinate of the unit hydrograph, which is in column 5. Column 5 is equals to column 4, which is the ordinate of direct runoff over the direct runoff. And once we get all the data, we can now use to plot for the we can use it to construct or plot the unit hydrograph. We have here an example 6.8. The peak of a flood hydrograph due to 3-hour duration isolated storm in catchment is 270 cubic meter per second. The total depth of rainfall is 5.9 centimeter, assuming an average infiltration loss of 0.3 centimeter per hour and a constant base flow of 20 cubic meter per second. Estimate the peak of 3-hour unit hydrograph of this catchment. B. If the area of the catchment is 567 kilometer squared, determine the base width of the 3-hour unit hydrograph by assuming it to be a triangular in shape. Solution. We have here a given of duration of rainfall exists, which equals to 3 hours. The total depth of rainfall, which equals to 5.9 centimeter. The loss due to infiltration at 0.3 centimeter per hour for 3 hours, which is equals to 0.9 centimeter. And the rainfall exists, which is equals to 5.9 minus the infiltration loss, which equals to 0.9. We get 5.0 centimeter. At peak of flood hydrograph is equals to 270 cubic meter per second. Then we have a base flow of 20 cubic meter per second. Then we get the peak of the direct runoff hydrograph, which is equals to 250 cubic meter per second. And the peak of 3-hour unit hydrograph, which is equals to the peak of direct runoff hydrograph over the rainfall excess, which equals to 250 over 5.0. Then we get the 50 cubic meter per second. B. Let B is equals to the base width of the 3-hour unit hydrograph in hours. Volume represented by the area of the unit hydrograph is equals to the volume of 1 centimeter depth over the catchment. And area of the unit hydrograph, which is equals to the area of the catchment times 1 centimeter. Since it is in triangle, 1 half times b times 60 times 60 times 50, which is equals to the 567 times 10 raised to 6 times 1 over 100. Convert to meters. B is equals to 567 times 10 raised to 4 over 9 times 10 raised to 4, which is equals to 63 hours. That would be all. Thank you.